Let us look at rationalization of the denominator, which frequently we will need to simplify our calculations. The rule here is just to multiply by 1. In this case, it is a camouflaged 1. In this case, square root of 2 divided by square root of 2. We notice that value is just 1. So if I now do the numerator and the denominator, I notice that I now only have to divide by 2. I can simplify it a little bit. Square root of 10 divided by 2. Square root of 10 is approximately 3, something divided by 2. So we know the answer is more or less 1,6 approximately. You can work it out with the calculator, but at least you can get a range for the value. Whereas if I look at square root of 2, which is 1,4 something, to divide by that is not as easy as to divide by 2. If you look at the next example, which is 1 over square root of 2, this is typically the ratio for cos of 45 or sine of 45. We often write it as rationalize the denominator, and we get a 2 in the denominator, and we get the square root of 2 in the numerator. When I look at the next example, our denominator is now not as simple as square root of 2 or one single term, but it is now 2 terms, 2 minus 5 times square root of 3, which is even more difficult to simplify unless we use a calculator. But what we will do is, we will, remember I said that when I have a division line, it's like we have a bracket or parenthesis around the numerator and the denominator. So in this case, I will multiply by, we call it the conjugate. And the conjugate is exactly the same as the same numbers as we have before, but now we have a plus when we have a minus there. We have a minus there, then the conjugate will have a plus. So to not change the fraction, I must multiply top and bottom with the same thing. In other words, I'm just multiplying by 1. So this will help me to simplify. When I now look at the bottom, at the denominator, I will just have difference of squares. So I'll have 2 squared minus 5 square root of 3 square in the denominator, and in the numerator, I will have 3 times 2 plus 5 square root of 3. This I can simplify by saying this is 6 plus 15 square root of 3, and the denominator becomes 4 minus 25 times 3, which in this case is 75 minus 4 gives me minus 71, the negative sign, 6 plus 15 square root of 3. If I now look at another example, this is typically what we encounter when we do limits. When we encounter limits, we often get the form 0 over 0. In this case, when x reaches or near 4, then we will get 0 over 0. But we do not want, we cannot evaluate this. It is an undefined or indeterminate form with limits. So we will encounter that a lot in first year mathematics. And so to get rid of this form, we will again multiply by the conjugate of the denominator. So we will get square root of x minus 2 times the square root of x plus plus 2, and remember we cannot change the expression, so we have to multiply by 1. If I then simplify the denominator, I get x minus 4, and in the numerator I have x minus 4 times the square root of x plus 2, which I can simplify when x is not equal to 4. This rationalization of the denominator and sometimes of the numerator, but more often of the denominator, is a very common technique to help us do limits in first year mathematics, and some of you already encountered limits in school, but not on the same level, probably not 0 over 0, so but you will encounter it in first year mathematics.